Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I just appreciate you watching. Thank you for joining me today, everybody. So, let's go over the plan really quickly, right? As I announced last Friday, I'd gotten a couple messages that basically said, I'm struggling with the concept of recursion with value methods. And that's understandable. So I finally just decided, you know what, let's just push it off a week. If you already turned your assignments in and you want to go back and, kind of fix them up, you could just kind of go back into the same replit that you turned in and fix them up. It will update with whatever changes you make to it. So that's a good thing. But we can just take until Thursday of this week to get those in because the current or the new module that we're entering in isn't due until the 30th. So if we can kind of push things off and work things that way, I don't necessarily think it'll take us 2 weeks for the next module. So having a week and a half for it, if we count the back half of today's live class and what we do next Monday, should be plenty of time to cover what I want to cover out of that. And so I pretty much decided that I was going to take the first part of our live class today and just kind of go back and talk about recursion with value methods, just because it is challenging. Right? It's probably something that's going to help everybody. And just so you all know, right, utilizing recursion with value methods is something that, I struggle with from time to time when I'm trying to figure out a particular algorithm. Right? Because you kind of have to flip the way that you think about algorithms and you forget, especially if most of the time you're just using iteration, which is what we're talking about next with loops. So usually when I'm doing it, I can't just do it off the fly. I have to kind of sit down, think about it, plan it out, write down what the steps that I need to do. And I can get there. But it is something that's a little bit tougher to wrap your head around. So I thought what I would do today is I'd kind of go through basically an inversion of your module assignment. So I thought I'd just kind of go through, like, it's odd sum, so it's looking for odd numbers between one number and another number. So I figured I would do even sum today, just so we could have something similar that you could see. We'll do it recursively using value methods, and along the way I'll kind of explain to you the different things that I'm doing and why I'm doing them. And I'll try to show you, like, what's happening in the different phases of the recursion as we kind of go through here. Right? And that'll be what we do for roughly the first half of what we're talking about today. And then we'll switch over to talking about loops. Right? So I have myself a replit here, Java replit. And I'm going to make an even sum here. So I've got my main method here, clean. We'll create a new method here. We'll call it even sum. So this will be public static int, right? Because we're returning an integer value. And we'll call this even sum. And we'll set it up with some parentheses for parameters. Since we are using recursion, we will need to take advantage of utilizing smart parameters here in order to be able to make this work effectively. And we'll add our curly braces here for the ability to enclose our method. And so we see we have the little red squiggle under even sum there. That means that it's not returning anything. Because if it's some sort of value method, it has to return something. So we can simply add a return 0 or return any kind of integer here out of the method to get rid of that little squiggle. And now we've completed what we call our stub. And so let's think a minute about what we need in order to make this happen. Right? We know that basically we have a starting point. We have an ending point. And we have some sort of tally at the end, right? We have some sort of sum at the end. And so this is even sum. This is going to be the inverse of what we have in our module, which is odd sum. So I'm going to take all even numbers between 1 and the end and tally them up. Now there is, I should say, if we were implementing a different sort of algorithm here, there is an easier way to do this, right? It's a little bit of a tricky way, and maybe if we have some time, we can kind of explain that, but we'd still kind of need, to some degree, what we're doing here to be able to do it. So either way it works. But our tally is just our ending sum. So our end value here we're going to get from our user, which means we're going to use scanner to get that. And I think the easiest thing for us to do is probably just going to be to go through writing a recursive method that doesn't actually do anything until we get to a good point. Right? So with even sum here, let's start out with an int starting point and an int ending point. And we'll come back and add our tally later. For the time being, we'll just have the starting point and the ending point be kind of showing us what's going on at any particular time in our recursive process. We'll go ahead and put scanner in here. I will initialize scanner at the class level just so I can use it in different functions. Not a requirement for this particular assignment, since the utilization of the input is simpler, right? We can just put it in main and just go with it, but we'll go ahead and do it in at the class level just to make it follow the practices that we've been doing. So public static scanner in equals new scanner on system.in. Semicolon at the end there. So now we have a scanner object that we can use in any function that is a part of our main class here. And so ideally, I'm going to use it in main. So I will just system.out.print enter top number. And then we will take and we will say int end number equals n.next int. Remember, since we're taking an integer in here, it is next int that we're dealing with here. And so now what we can do here is we can call our function. And so when we call our function, I'm not going to call it in a print. I'm going to put print statements in our integer value function, but it's going to do a similar thing where it's going to run our function and it's going to return the 0. So right now I'm just going to call even sum. Started in my start number, which is 1. and my end number, which is end number, which we've declared here. And so via parameters here, I'm able to take two values, my starting number and my ending number, and pass them into my even sum function. So from here, we can kind of start to deal with this and work with it. Right, so what I want to do is I want to check to see every number between where things start and end. And if start gets to be greater than end, if it passes that endpoint, then I want to return a value. So in this case, we're going to say if start greater than end, we are going to return, for right now, 0. Right, so if I have a conditional, every path in my method has to have a return value. Right, so in this case, I need both of these return statements right now. I need this return statement for the if condition, but I also need this return statement that's outside of that if condition. Because through every path through my method, if I'm going to be recursing, or even if I'm not going to be recursing, even if I'm just using conditional statements here, I need to return a value out at the end. And it seems to be having a fit, even though I've not actually run anything here. There it goes. Replit might be having a little bit of a problem here. We'll just play with it and go by ear here. But then I want to check to see something else, right? So else, if they're not the same, what I want to do here is I want to, let's say system.out.print line the value of start at that particular point. And then we can return our recursive call. Right? And so we can return our recursive call because eventually we're getting back here. Right? Eventually we're going to hit a path that's going to get me to this integer. So eventually, if I return a recursive call out of here, return even sum start plus 1 end, then eventually I'm going to get to this point where start is greater than end, and it's going to return 0, and it's going to exit the method, right? And so with that, this return 0 here has become redundant, right? The second one that we have here, this return 0 on line 23 has become redundant, right? Because I have a return statement coming out of both of my paths. I have a return statement here coming out of my if condition and a return statement here coming out of my else condition. Since I have a return coming out of if and a return coming out of else, every single condition that I test in this program will trigger one or the other as true. So both of these return statements in my if and else satisfy having a return condition through both of the paths. So the return I have here on line 23 becomes redundant, and I can delete it. Right? I just have to make sure that I have a path that's going out of both sides. And so now essentially what I've built here is a recursive counter. Right? And we're doing the system.out.println start here, just so we can see each number being counted. But at the end of the day, what's being returned back is 0. And so when this resolves, here in main, it's resolving a value of 0. The only reason that we'll see other numbers being printed out is because this else condition exists. All right, so let's run it. Whoops. Oh, you know what I did? Or what I didn't do, some of you might have caught it out there. I did not import scanner. Import java.util.scanner. Got way ahead of myself and forgot to import scanner there. So when I was referring to scanner, it had no idea what I was talking about. Now let's run it. Enter top number. Let's put in 10. And it gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I put this even sum call here inside of a print statement, then what we can expect, well, let's just see the outcome, right? I know what we can expect. You could probably guess what we can expect. But let's just see what it does. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0. Because each time it's recursing through this particular method, it's hitting this system.out.println start, printing the value of start, jumping back up to the top with start as a +1 value, doing it all again. The last thing that it does is it returns a 0 here, which is what gets returned into the print statement. So that's what's happening there. Now, how would we keep a running sum of our even numbers, right? Like this is an unnecessary line here, right? We're only using this because it's kind of visually showing us what's happening at any particular time. So what I need here, just to make my life really easy, is I need some kind of tally value, right? I need some kind of sum value here that, you know, if my numbers meet a particular condition, I can add it to that sum. Which means I would need to add that tally value in my call here, and that's going to be a 0, right? Because I'm going to add anything to 0. So in this case, what I want to do is I want to create a conditional statement here. And we'll say if start modulo 2 == 0. We're going to print the value of start just so we can continue to see it. But we're also going to take our tally value here and add the value of start to it. That way, whatever tally was before, it gets the value of start added to it. So I can just type tally plus equals start. And then since we have tally here as our value, I can just add it to our method here. Now I could, if I wanted to, right, we could like add a couple of other recursive calls here. Right, for example, this could be return that, this could be this here, that there, and then that there. Right, that way we're only, or having it the other way where we are incrementing the tally value and then calling the function one time. Either one of them work. Either one of them are equally efficient, because in both cases you're having to recurse the function, right? So it doesn't really matter. And so if we check this out here, we can actually see our values. So what I would like to do here is just have them side by side. So I'd like to print out the start value and then system.out.print. And if I'm going to have to concatenate anyway, I may as well just concatenate in there and leave that a print line. So we'll put a space concatenating the start value and the tally plus start value. So we're still not returning anything yet from here, right? Everything's just still being done through print statements in the else condition. Right, so let's test that out. We're entering our top number, we'll say it's a 10. And we see our values here. It's throwing us just a little bit of a problem, right? Because it is concatenating our integers there. Which is less than desirable, but it's fine. We can see that we're only getting 2, 4, 6, 8, 10. And that our value that we're returning here is a higher value. So let's put in our output here where it needs to be. Let's get rid of that print statement. And let's put our output as this return statement that is in the if condition. So remember that first if condition is waiting for it to break. And so we are only going to return that value when it breaks. So when all is said and done, then that's going to be the value. So the tally value is actually going to be the number that we return. And so we can system.out.print line the result of even sum, 1, end number, and 0. So we see our even sum function here is relatively small, right? If we do things right. Might have to edit this a little bit, but let's just see what goes on here. Right, we only have two recursive methods calls here. One if it is even, in which case we're adding that tally number, or adding that start number to tally and running our function again. And if it doesn't meet that condition, then it's just boop and running our function again. So if we run this now, let's start out with something simple. Let's start out with, say, 5. And we get the value 6 returned to us, which is what we should expect, right? We're targeting all the numbers 1, 2, 3, 4, 5, so all the even numbers between 1 and 5 are 2 and 4. And so we get, when our start value is 2 coming through, it adds 0 plus 2, making that 2. Then when our starting value of 4 is coming through, that's already 2. And then we add 4 to it, which makes it 6. 2 plus 4 is 6, which is exactly what we would expect. And we could do it with any number here, right? 10, our odd sum is 30. 2 plus 4 plus 6 plus 8 plus 10. Right, pretty simple. And we can see how little code was actually used here to get these values. And one of the things that we could do here is we could kind of reformat this function a little bit and just see what all the values are. So if we did that, we would just be adding every value that goes through the situation there. Goes through our recursion. So if I wanted to say 3 here, this should be 1 plus 2 plus 3, which is 6. Right? 1 plus 2 is 3, plus 3 is 6. Let's do it with 10. We get 55. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. 55. Now there is a bit of a tricky little mathematical algorithm. If you wanted to figure it out, right, that basically says, okay, like, I can take the sum and I can do some manipulation to it, and it gets me to where we want to be. But really, it's easier to just sort of do it the intended way. Obviously, and if I change one character, that's all it would take to take this even sum and turn it into odd sum, is by changing just one character in this program. But that gets us what we want, right? Like, that gets us a recursive method that goes through, finds all the even numbers between one number and another number, adds them together, and displays the result. And you can see, right, our n number needs to remain constant, so we just push it all the way through. Pretty simple. And so then with recursion, right, this is so fast that I could go with a big number and we get it to spit out something almost immediately, right? 1,254, it immediately spit out 393,756. Right, let's see how big we can get before it starts to noticeably slow down. Let's go 32,365. And there's our Stack Overflow. And that's because it's probably getting me into a situation where I'd need a long for that, I bet. I bet if I turned this into a long and turned this into a long, and then did something like 32,365, that's still not enough. Pretty strange. It's just too big there. That's Java for you. All right, but a minimal amount of lines of code there. And we're good to go. Now, with that being said, we're kind of in a place now where we can forget about recursion. Not completely. Right? Not completely, but we can more or less kind of forget about it now that we're talking about loops. And loops are a similar process to recursion, but they're not recursion. Right? If you'll remember back to when we talked about recursion several weeks ago, we said that there were 3 laws of recursion. And the 3 laws of recursion was you had to have a base case, you had to have a terminal case that will stop the loop from running. But then you also had to have a self-referential method call or a self-referential function call. And that's really what separates recursion from iteration, is that recursive call. Right? When we're dealing with iteration, like we are here, iteration is siloed, iteration is isolated. We won't be making any extra function calls inside of a loop, not one that we don't have to make. Right, so when we start talking about a loop here, just what exactly is a loop? A loop allows us to repeat a process until a condition is met, right? Which again is going to be very similar to recursion. The only thing that really sets apart recursion and iteration is that lack of a recursive call. And so each step in a loop is called an iteration. Whereas each step through our recursion, we'd say the function is running recursively. Each step through a loop, it is called iteration. And it's great for basically running the same things that, our recursion was good for, right? There are certain instances in which you'd use one over another. But it's great for running through an input and applying these same conditions to each part of it. For example, like sorting. And so we'll start out talking about while loops. And we'll pick up next week with for loops and enhanced for loops. And perhaps do while loops if we have time. But a while loop performs an iteration while a condition is true. So if you remember conditionals, a conditional is if this condition is true. And a while statement is as long as this condition is true. Right? So we can think about our while statements very similarly to the way that we would think about our recursion. Or scratch that, reverse it. We can think about our while statements very similarly to the way that we would think about our conditional statements. Just that with our conditional statements, they're going to run once, and our while statements are going to run multiple times. And so let's look at a sample while statement here and just kind of break down what's going on. So we have a void method here called countdown, right? We're looking at a simple countdown method here. And we have our base condition here. While n is greater than 0, right? So if this were a conditional statement, an if statement, we'd say if n is greater than 0, do something. In our while statement here, we're saying as long as n is greater than 0, do something. Then we do the something. And then we take the n and we move it toward breaking the condition so it breaks the loop. Right? So if we imagine this, right? Let's say we take this value n, it becomes 10. The first time this condition is run, n equals 10. And it prints 10. Then it subtracts 1 from the value of n and jumps back to here, the top of the while loop. So at that point, n is 9. Right? Because we've reassigned it the value. So 9 is greater than 0. That is true. So it prints out 9 and subtracts 1 from the value of n, which makes that 8. 7, 6, 5, 4, 3, 2, 1. When it gets to that point when it's 1, it's going to print out 1. 1 minus 1 is 0. And then 0 is not greater than 0. 0 is equal to 0. So it'll skip what's in this while block and move on to the next thing. Right, which is one of the things that makes our conditions, or that makes our iteration easier than our recursion. Right, because I can have statements before, make that a different color, before and after my loop, and they don't get impacted when my loop iterates. Right? You know, if you remember back to recursion, if we recursed a function, it would recurse everything in that function. So we'd have to do sort of weird things with variables and have them in different methods and things of that nature, so that we wouldn't reset a value or we wouldn't whatever, right? Because every time you recurse a function, it reruns everything that's in that function. But with our iteration here, our loops, our while loop, and our for loop, which we'll talk about next time, it only runs what's inside of that particular block, which is beneficial to us, right? Flow of execution for a while loop, it evaluates the condition, yielding either true or false. This is just kind of demonstrating or explaining what we just kind of walked through there. If the condition is false, it skips the body and goes to the next statement that's after that loop. If the condition is true, it executes the body, and you go back to step 1. Right, so now let's do an example that we just did. Let's do that thing that we just did here with recursion. But let's do it with iteration, so we can see how it's different. I'm going to comment that call out. So that takes and basically nullifies that whole method there. And we're going to write ourselves a new method here. And we'll call this one, this will be a public static int. We call that even sum. So let's call this even int, or even iter for even iteration. We will add our parentheses there for our parameters. And we'll add a return 0 statement here to complete our stub, right? Just to get rid of all the little squiggle lines. So let's talk about the first thing that's going to make this easier, right? You can see here we have 1, 2, 3 parameters here that we have to reflect in this method call. I don't need that here, because since that while loop is isolated as opposed to my recursive call, which reruns the entire function, I can declare those other 2 parameters as variables inside of my function. So all I really need to be able to do here is get the user input that we're getting up here in main into here. So all I really need is an int end in here as a parameter. From there, I can take and I can set up a int start and have that starting at 1, and an int tally and have that starting at 0. Right, so we don't need to have them as parameters, because if we tried to initialize them here inside of even sum, and when we recursed our function, every time we recursed our function and it got back up there to the top, it would reset those values. But here, we're saying everything is contained in the while loop. What goes on in the while loop doesn't really touch the things that are around it, unless we were specifically, like, say, reassigning a value. It's not going to restart something and reset everything back to the way it was. So we can just leave these calls here and everything is all well and good. So we could say while start is less than or equal to end. So now we have a while loop here. And so as long as start is less than or equal to end, it's going to do the following thing. We're going to check to see if it's even. So if start modulo 2 equals 0, then we're going to take the value of start, or we're going to take the value of tally, and add the value of start to it. The other thing that we need to do is we need to be able to take start here and increment it so it gets to a point where at some time this condition will be false. If we don't do that, we'll end up in a infinite loop because we're not actually changing the value of start to step it toward the end value to break it. So I need to do that if the number is even or not. So I'm going to go outside of that if condition there and add a start plus plus. And so that's it, right? I don't have to worry about different paths to my return statement because I'm not doing recursive calls here. So I don't need different return statements for my different paths through my method. I just need a return statement on the output that has my final result of tally to send it back out of my function. And so these two methods do the exact same thing, right? You can see that maybe the code here is just a little bit shorter than the code here, or just a little bit fewer lines. They might be just about the same number of lines. I think the only thing that's making this one just a little bit shorter in terms of line length is that we have our different parameters that are doing this job. But now we can call our function here system.out.println. And this is going to be even iteration, and I just need to pass into it the end number that we're getting here. And so now we can already still see over here 1, 2, 3, 4 gives us 381,306. 381,306, the exact same results, right? Like if I took that and made it with smaller numbers, like say 5, I get 2 and 4. There, 2 plus 4 is 6. Right, so we can see there that it's the exact same logic. It's just done iteratively instead of recursively. And iteratively, iterations are typically a whole lot easier for, people who are getting started with programming to wrap their heads around, as opposed to recursion. But there was a long time when recursion was the only way we had to do it, right? And there are instances in which doing something recursively is going to be more efficient or better than doing something iteratively, although it doesn't happen a whole lot. Right, so from this point forward, if you need to do something over and over and over again, I encourage you all to do it with a loop, right? And so a while loop is one part of a loop, right? And you can see that the while loop here has 3 distinct parts to it, right? It has a starting value, it has an ending value, and it basically has a stepping value. And one of the things that we noticed as we were kind of going through time is that every single instance of this as it occurred, we'd write all these while statements, and we'd say, well, we have a starting value, we have an ending value, and we have this sort of stepping value that gets our starting value closer to our ending value. So, since we're programmers and we like to automate our lives easier, is there a way that we can take this pattern and formulate it into a different sort of loop that does the exact same thing? And that is a for loop, which we will talk about next time. So this will be where we'll stop for today. If anybody who's here with me live has any questions, go ahead and throw them in chat now. We got exactly as far as I wanted to get today. We recovered the concept of recursion, and we started talking about while loops. Next time, we'll talk about for loops, and we'll talk about a few other things that'll be important for us to know. So we'll just hold here for just a moment, just in case anybody who's here with me live has any questions. And of course, while we wait, if you are watching the recording and you have questions, send me an email message, send me a Teams chat. Let me know and we will answer them to the best of our ability. So since I am not seeing any questions in the chat, we'll go ahead and stop here for today. Thank you all for watching, and we'll see you next time.